Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on resistance in rough pipes. So the question is given here. The water is flowing through a rough pipe of a diameter 500 millimeter and length is 4000 meter at the rate of 0.5 meter cube per second. Find the power required to maintain this flow and take average height of roughness as k equal to 0.4 millimeter. So we need to find out here the power required to maintain this flow. So before that, let first identify the data given in this question and write down this. What are the data given in this question? We can write easily from this first line itself. The diameter of this pipe is given d equal to, so we can write this is 500 millimeter. So this one we can write this is 0.5 meter. And the length is given, so L given, this is as usual like a meter given, so no need to change any unit for this. So this is 4000 meter, and the rate of flow, so that is 0.5 meter cube per second. So this one we can write the rate of flow is nothing but discharge. So discharge is given, this is 0.5 and meter cube per second. Find the power required to maintain this flow. Average height of roughness is k equal to, so average height of roughness, that is k. This one we can write 0.4 millimeter. This one also we can convert into meter cube by converting this into 0.4 into 10 to the power minus 3 meter. So here first let's see what need to be calculated here. Now we need to calculate the power, we need to calculate the power required to maintain this flow. So we know that the power required equal to, we can write this is W into HF. W into HF by 1000 we can write, and this W is nothing but the weight. So in place of this weight we can write the small w into Q into HF by 1000. So this small w is nothing but the specific weight, and this is discharge. So again we can write in place of this small w, that is rho g. So rho g Q and HF by 1000. So now see, this is rho is density, g is the gravity value, and this is Q equal to discharge, and HF is the head lost due to the friction. Now all these values are known to us except this HF value. So again from this equation, again we need to go back to this next one, like how to calculate the HF value. So HF is, we know that the head loss due to the friction, that is nothing but the Darcy-Weber's equation. So that one we can write, this is 4F LV square by 2dg. So this is the formula for head loss due to the friction. Now here again we can see 4FLV square 2dg. So diameter d given, g value known, L given. Now here we need to find out the F value and V value. So this V value is nothing but, we need to consider when it is flowing through the pipe, and with the diameter also given, length also given, and here the value of velocity, we need to consider the average velocity. Anyway, the average velocity also can be immediately identified from, this is discharge by area, because we know that Q equal to AV, that is the discharge formula. So from that formula we can write V equal to Q by A. So A means the diameter is given, from here we can easily identify the A area value. So that is Q equal to 0.5, and this is area pi by 4 d square. So we can write pi by 4 into 0.5 square we can write. So we can find out the velocity value. Then here velocity, what is required, we got it. Now the next thing is here friction factor F. So the friction factor, actually for the rough pipe we need to consider one equation. So anyway, so that we are going to solve. Now the basic things what we have identified from the data, these are the data are there. Now we are going the reverse way, like what need to be calculated first. Initially I have written the formula, power, this is nothing but W into HF by 1000, or we can write directly rho g Q HF by 1000. Okay, so here H is the nothing but the head lost, due to the friction, and hf equal to 4f lv square by 2 dg. This is nothing but the loss of energy due to the friction, or we can say the Darcy-Weber's equation, which you already have derived previously. So by this we can calculate the hf value. Now before calculating this hf value, we need to identify this velocity, average velocity u bar, and another one f is there. So let's find out this first. So this one we can write 0.5 into this 4 and divided by here, this is 0.5 pi into 0.5 square. Okay, so this one also we can calculate here, like 0.5 into 4 divided by pi into 0.5 to 0.5 bracket close. So this is nothing but 2.54. This is meter per second. Anyway, this velocity value we got. Now we'll go for the calculation of friction factor. So this friction factor we need to consider, that is for the rough pipe. So we know that we can write 1 by root over of 4f equal to 2 log 10, and this equation we got in the in our last lecture. We have discussed about the derivations. From there we got this equation from the Nikud's experiment. He gave this equation 1 by root over of 4f equal to 2 log 10, and this is r by k plus 1.75. So here the value of r is nothing but diameter given, so radius we can calculate from here, r equal to 0.25 meter. From here we can got it. Okay, now k value already given, so we can write this 2 log 10, and this is r equal to nothing but 0.25 divided by k equal to 0.4 into 10 to the power minus 3 bracket close, r by k plus 1.74. So this is the value. Just we need to solve it, all these things, then we can get it. Like this is 1.74 is there, and this value will be solved it, we'll edit in that. So let's find out this. So this one we can write what, 0.25 divided by, this is 0.0004. So this value we get 625. So log of this value, okay, into 2. So this is 5.59. So now what we'll do, this 5.59, let it write it here, 5.5917. Okay, that is leave it, then 1 plus 74. So what I'll do, this plus 1.74, so 7.33 we got here, 7.33. now 7.33 you can write. Now what I'll do here, I'll take this one root over of 4f, I'll take that side, so this side will be 1 by 7.33, and the another side will be there, root over of square root of 4. Now just what we'll do, we'll just remove this f. That means this a value we can write by squaring of this other side. So 1 by, let's write here first, 1 divided by 7.33 0.136. So what we can write here, 4f, let's write 4f. That means I'm removing this square root, so other side will get 0.136. So 0.136 square, and this one f we can write again, the value of f I can write what, now this is 0.13 square divided by 4. Anyway, what we got here, this one we just can square root of this. Is not square of this one I did, or what, root over square. Anyway, let's write in this way. Otherwise simple, 0.136 into 0.136. Yeah, same thing I did then, square only. Okay, this square divided by 4. So 0.0046. 0.0046. This is the value of F. Okay, friction factor. Now all the value we got here, now we can calculate the HF value. So now we can write here HF equal to 4 into 0.0046 into L. L equal to 4000 is there. So that one we can write 4000. Again we can write this, what is that? LV square, V square. V is here, average velocity 2.54. So this one we can write 2.54 square divided by 2 diameter 0.5 into dg. G is nothing but 9.81. Now let again solve this. So what I'll do, 4 into 0.0046 into 4000 into 2.54 into 2.54. Yeah, so this is the value 474.83. Now we'll divide this term, 2 into 0.5 into 9.81 bracket close, 48.40. Now we got 48.40 for the HF value. So this one we can write 48.403. So anyway, we can write the same thing, HF this much meter. Now what we'll do here, yeah, next is finally P value. So P value, directly we can put the value of this, P equal to rho value. This is rho GQ. So rho is nothing but, you can see the water constant, water is taken here. That means the density of the water is nothing but 1000, and rho G, this is 9.81 into Q. Q is given 0.5 meter cube per second, and this is Q. HF we got here. This is 48.403 and divided by, this is 1000. So now we can see this 1000 can be cancelled, and what are the remaining value, we can just multiply it by 0.5, again multiply 4.81, so we'll get 116.4. so this much kilowatt. Okay, this one I have done 4.81. No, that should be actually 9.81. Anyway, we will do one thing. So divided 4.81 into 9.81, 237 actually, 237.48. This is actually 9. So near about 238 kilowatt P. This much power is required to continue the flow. Okay, this is the final answer. So when the flow is there in the pipe, to continue to maintain the same flow, how much power is required in this, when the roughness is there, when the average height of roughness is there in the rough pipe. Anyway, I hope you understand. Very simple. Data given first identify, then what things need to be calculated. You can write this. If you know the formula, it will be easy to calculate. Then one by one, which data is not given, let calculate that, and which data is given, that is no need to calculate, just you put the value in place of that regarding parameters. So again, few formulas need to be remembered, like Q equal to AB. So AB velocity you can calculate, and this is HF value is nothing but the Darcy-Weber's equation, head lost due to energy, that major loss we can say. Okay, and in this HF again one more term is there, this F term. So that is the friction factor for the rough pipe, so which we have just derived in the last lecture, in the last video lecture we have seen. So then once you calculate these three formulas is there, that is enough to solve this problem. So I hope you understand how to solve this kind of problems. If you are having any kind of query and doubt regarding this, you can give a comment in the comment box. Thank you all.